which we did in the other lecture. What's more interesting is what happens when we change the instrument or the product characteristic. So let's first think about what would be socially optimal. So we know in terms of the price, the socially optimal thing would be price equals marginal cost, right? What about in terms of the this instrument rho? Well, the total social value, right, is the integral over all the people who are participating of U of the instrument minus the cost, right? So it's the utility that everyone who participates gets minus the cost of providing it to them. If we take the derivative with respect to rho, but we want to hold fixed n, right? We want to hold fixed the number of people. How do we do that? Well, we have to take the derivative using Leibniz's rule again. With respect, we have to figure out, when we raise rho, how much does p have to change in order to hold fixed n, right? And then we can just take the derivative by taking the derivative with respect to n, adjusting p and rho in such a way as to hold fixed the number of people participating. Okay. So, Brett Lombardi here? God, I don't understand how everyone that I do shows up to the lecture. Okay. Or are people just pretending not to be here? And okay. So what we want to do again is we want to figure out, in order to hold the number of people participating fixed, if we increase the level of the instrument, how much does the price have to rise or fall in order to hold fixed the number of people, right? And to do that, we can just set up a simple equation. We want how much the number of people changes when the instrument changes to be 0. And there's two effects there. One is the effect that directly the change in the instrument has on the number of people. And the other one is, well, the price is going to adjust, and that's what we want to solve for, times the direct effect that the price has on the number of people. And we know that this is negative m times this, right? And then from Leibniz's rule here, we get that the effect of the change in the instrument on the number of people is u prime, the derivative of the thing along the boundary. So it's over the set of marginal people, what is their marginal utility for a little bit more of the instrument?
That's like an expected marginal utility of the marginal people.
Exactly. So that's exactly what I was going to define. So this is the average marginal utility of a marginal consumer is going to be tilde u prime. Right? That's their average value for a bit more of the instrument divided by m. And so what do we get? This thing becomes m times u prime of m. This becomes negative m, and we get dp d rho is just equal to the average marginal utility of the marginal people. So that's quite intuitive. If we raise the instrument, price is going to have to rise by the average marginal utility for the instrument of the marginal people in order to keep anyone from either leaving or entering the platform. Yeah?
Right, maybe another understanding, but are you solving for rho that maximizes the social?
We're going to do that, but we want to be able to hold fixed the number of people at the same time. The reason why we want to do that is because otherwise we're going to be worrying not about the level of the instrument, but rather just about the fact that there's socially too few or too many people on the platform. So we really want to focus on the instrument relative to price, that trade-off, not the trade-off that we focused on in the other lecture, which was like, what overall do you want the number of people to be? So we want to be able to hold the number of people fixed. And in order to do that, we need to do this little technical step.
Can you set up the Lagrangian and
You could do that as well. That works as well. I sort of like this way better. Andre can explain to you why we like this way better. But it's, you'll see it. It works out very nicely. But we just need to make sure we really understand these steps here. The point is that in order to hold fixed the number of people, when the instrument increases, the price has to increase by the average marginal utility that marginal people place on that. Right? And that's very intuitive because the marginal people are the ones who are substituting in and out. Right? If you raise the price by the same amount on average that they like having the extra instrument, on average no one's going to substitute out. Right? Okay. So then it becomes really easy to take the derivative of social welfare with respect to rho. Sarojini, Rao?
Yeah.
Could you try doing that? So now that we know how much the price changes when rho changes, right? It changes by this much. How much does that affect this social welfare expression when we increase rho? Anyone else? Yeah? Yeah, exactly. So you were doing this stuff along the boundary, right? What you're doing along the boundary was great, but the point is that actually along the boundary, there's no effect, right? Because everyone here, the price is set equal to marginal cost, right? And we're keeping the number of people the same. So there's like no one substituting in and out, really. So the only effect is on the interior of the integral, right? So that's what makes it so nice. You don't even really need to use Leibniz's rule. You just forget about what's going on in the boundary and just think about the interior. And that lets you get just that you get the derivative of utility with respect to rho, and you get the cost. Okay. And so now, what is this here? Andre, what is this? You're my average man. What is this?
Expected marginal utility of people
Who are participating, yeah. Not who are marginal.
No, in the market.
In the market as a whole, yeah. So this is U bar prime, which is the average marginal utility of people who are participating. Right? So what this says is the optimum is when U bar prime is equal to the marginal cost of providing the instrument, bam. So, again, the social optimum is to set the marginal cost of quality equal to the average marginal utility of an average consumer times the number of consumers. Right? Or another way of putting that is the average marginal utility that people should get should be equated to the average cost of providing that per person. Right? That makes perfect sense, right?
So this is the average marginal utility of the average consumer participating, or?
Participating, not the average marginal consumer. Okay, what about, so it equates the marginal cost and benefits to the average purchaser, right? Now, what about the derivative of profits with respect to rho? And I was going to ask Avi about that, but I don't think Avi's here either. Anyone? Profits is just this, right? N doesn't change, only the price changes. Yeah. That's so simple. So now you see why it's worth going through those steps, because now it's just completely trivial to do this, right? So it's just U tilde prime times N minus the cost, and so we get a different expression. This is the easy part. Brenda. Yeah, what is the price we offer? What's the profit maximizing thing that we know?
That the firm is gonna equate marginal cost equality to the average marginal utility of the marginal.
Exactly. There we go. So he equates it to the average marginal utility of the marginal consumers rather than the average. So they cater to the marginal consumers, not to the average consumers, and this is called the Spence distortion. monopolies distort quality by taking into account the preferences of marginal consumers, when it would be better if they took into account the preferences of average consumers. And quality will be too high if the marginal consumers value it more than the average consumers, too low if the marginal consumers value it less than the average consumers. And one thing to think about, though, is that, and there's actually a famous book by Albert Hirschman about this, is that this is assuming that the only way that an inframarginal consumer can hurt the firm is by stopping to buy its product. Another way they could do it is they could complain about things and so forth, and that might influence the decisions of the firm. So he's got this book, Exit, Voice, and Loyalty, that's all about exactly this issue. Okay, so let me give a simple example of this. So this is Hotelling's model. Consumers live along the line. You can think of it as a location of a store. And consumers also live along the line, and it's costly for them to travel to the store to purchase the product. Consumers always buy one of two firms competing products. And this is technically oligopoly, but basically the same logic. You know, the Spence logic is going to show you exactly what's going to happen. So the two firms are going to start somewhere, and Spence is going to say you should cater to the marginal consumer. Well, if everyone has to buy from one of the two firms, who's the marginal consumer? It's the one that's halfway between the two firms, right? And so everyone's going to move towards the other firm wherever they start, right? That's just the Spence logic. And that means that any equilibrium has to be where they're at the same spot as one another, right? Now imagine that's not in the very middle of the interval, right? Well then, I could move just slightly to the side of the other guy and get the majority of the people, right? And so it's always going to have to be right where the median person is. So it could be at the center of the interval if there's uniform distribution, but if there's non-uniform distribution, it'll be at the median of whatever it is. And so that gives us Hotelling's law, which is that in this very simple, simplistic model, both firms end up at the center of the interval. So this is a very classical result, and it says that, you know, this is a real problem. Because everyone's catering to the marginal guy, rather than to their inframarginal people, everyone's worse off. It would be better if the two firms were at 0.2 and 0.75, 0.25 and 0.75, but instead they're at 0.5 because they're all catering to the marginal guys. However, it's not completely obvious, more generally, that there would be too much clustering. There could be too little clustering. So for example, if there were people who were not just for sure going to buy the product, but might actually leave the market, or this was a vertical thing and not just so horizontal with everyone disagreeing, it's very easy to show that there can be cases when there's like too little catering to the marginal guy in terms of the competition between the two firms. And therefore, more intense competition between the firms is a good thing rather than a bad thing. Here it's bad, this is driving everything to the center, but it could well be good if the people who are switching between the two firms are more representative than the people who might exit the market, right? Because firms are always going to cater to their marginal consumers. If the firms are a monopoly, if they merge together, they'll cater to the people who are marginal to exiting the market, right? If they're competing, they're going to cater both to the people who are marginal to exiting, but also to the people who are marginal in between them. And the key question is, are those exiters or the switchers more representative of the average consumer, right? And that's the key determinant of whether the firm is going to do the optimal or suboptimal. So Spence, again, acts as a useful baseline. This Hotelling model is a useful baseline, but sort of the more general logic of all these types of situations is the Spence logic. You're catering to the marginal guys, and that applies much more broadly than this very simple thing where everyone's along the line and everyone's going to purchase and so forth. This is just a little picture of the Hotelling line. So the idea is that there's like, you know, here's this beach, and you can locate it at any point along the beach. Here's the point that everyone converges to, and here's the